everyone. Welcome to section 4.4, physical and chemical changes. By the end of this, you should be able to explain the relationship between macroscopic characteristics and bond interactions for both chemical processes and physical processes. So in a physical process, we see a substance undergo a change in properties, but not a change in the composition of the substance. So this is things like phase changes or mixture separations. For example, the melting of ice into liquid water. When water melts, the chemical makeup of water does not change. There are still two hydrogen atoms covalently bonded to one oxygen atom. That should be oxygen. In ice and in liquid water. However, the physical properties did change. The particles now have a different arrangement. Okay, they're more spread out, or not more spread out, they have a more irregular shape or arrangement. They flow past each other instead of being in a rigid crystalline structure, so they have changed. In the picture to the left, notice that the covalent bonds between hydrogen and oxygen are the same in both pictures. However, the density, which is a physical property, is different. Okay, so the density of solid water or ice is much lower than that of liquid water. So the density, a physical property, has changed. Another example of a physical process is a mixture separation. When mixtures are separated using a physical process, their nature doesn't change, just their form. Mixture separation techniques include distillation, filtration, and chromatography, all of which we have discussed before. The photo below shows a mixture being separated using a filter. So only some of the components of the mixture pass through the filter, and thus those two are separated. In a chemical process, a substance is transformed into a new substance with a different chemical composition. During chemical processes, bonds are broken and formed. Examples would include chemical reactions where two elements bond together to form a compound. A compound is broken down into its elements or into a new compound, or neutralization reactions that produce water as a product. These we have discussed previously when we talked about types of reactions, and we will continue to discuss them moving forward in more detail. The picture to the left represents a chemical change. Notice that bonds between atoms are separated and new bonds are forming. The intramolecular forces, are broken and reformed. We can see that because the arrangement of all the atoms in there is different on the reactant side than the product side. So atoms are moving around and you're still having the same total number of each, but they are now attached or bonded to different other atoms. Sometimes an argument can be made that a physical process involves a chemical change. The dissolution or dissolving of salts into water is one of those cases. If we look at the picture to the right, when a salt is dissolved in water, the ionic bonds between the sodium and chloride ions are broken and a new ion-dipole interaction is formed between the ion and water. Now, you could argue that. Generally, though, we say that this is a physical process because we can still evaporate off the water, which is a physical change, and get the salt crystals back. So it's not permanently being chemically altered, and with a little bit of energy, we can reverse that process and separate them back out. Okay, so now we're going to look at some different reactions and determine if it is a physical or a chemical process, and then look at the types of forces, intra or intermolecular, that are broken and formed during the process. So when we look at this one, we see we have methanol, CH3OH, and it's going from a liquid to a gas. That process sees a physical change in state of matter. So this is a physical change or a physical process. And those physical processes break intermolecular forces. So intermolecular forces are when we separate molecules. Okay, so we make the make two different methanol molecules move farther apart, going from a liquid to a gas phase. So that is an intermolecular force that is being weakened. Looking at the next one, we see two distinctly different reactants and one distinctly different product, right? So our atoms are being rearranged. So this is a chemical process. That means that we are manipulating and forming and breaking intramolecular forces. The bonds are changing. Okay, if we look at the next one, we see that we go from one reactant to two distinctly different products. Again, we have a chemical change because we are rearranging the chemical composition of the substance that we're looking at. And so that means that we are manipulating and changing the intramolecular forces. Continuing forward, we see we are going for carbon dioxide from a solid to a gas. That is a sublimation process, which is only a physical change in the state of matter. And so that means that we are breaking the intermolecular forces. And we know it's breaking because solids are much closer, so have stronger intermolecular forces than gases, and we're going from a solid to a gas. Okay, moving to our WeDo, I want you guys to draw and label a diagram of hydrochloric acid. So you first need a key identifying which is hydrogen and which is chlorine, becoming a gas. Explain how this is a physical process versus a chemical process. Okay, so please pause the video and do that now. Okay, so you should have had something that looks like maybe a liquid here where they're close together and you're showing intermolecular force interactions or attractions between the hydrogen and a different molecule's chlorine. Okay, and do those as dotted lines. And then you have some that are in the gas phase to indicate that this is a process, that some are becoming a gas. Okay, since this is a state of matter change, it is a physical process. So intermolecular forces are being broken. It is a physical process because the state of matter is changing, the physical state that the substance is in, but the chemical composition of the substance is staying the same. So it is not a chemical change or a chemical process. Okay, so that concludes 4.4 notes. Please answer the You Do questions, check your work, and thank you for tuning in.